Hello guys, welcome to my channel Data Science with Gagan. This is Gagan Gupta and I'm a data scientist. This is my first video on YouTube, and from now on I'm going to share data science projects in my videos where I will try to cover up all the data science projects like deep learning projects, machine learning projects and so on. So for today I have a project for you guys which is text classification using LSTM, where I will unlock the power of LSTM for text classification. So let's see. So first I will take you all through its introduction, what is LSTM and how its architecture looks like, and then later on we will look at its implementation where we will use LSTM in our ANN for text classification purpose. So let's start with LSTM. What is LSTM? So LSTM stands for long short term memory, and it is a type of RNN which is recurrent neural network, and which is designed to model long term dependencies by addressing the problem of vanishing gradient, and it enables better sequence prediction and learning. And here in this picture we can see its architecture, and from here we can see it uses three gates. First gate is forget gate, second input gate, and last one is output gate. So forget gate decides which information from the previous cell state to forget. Basically it outputs a number between 0 and 1 for each number in the cell state. Input gate determines which new information to store in the cell state. Basically it has two parts. First input gate layer, second one is candidate layer. So input gate layer decides which values to update, and candidate layer creates a vector of new candidate values to be added to the state. And finally output gate determines the output based on the cell state. It controls what part of the cell state make it to the output. As we have been discussed about LSTM and its architecture, now it's a time to have a look at its implementation. So here in this cell, I'm just importing all the important libraries like sklearn, NLTK and TensorFlow. Out of them, sklearn and NLTK I'm going to use for the data pre-processing purpose and TensorFlow for the modeling purpose. In this cell, I'm just reading out the data from the directory, and this is how the data looks like. So there are four major fields like title, body category and subcategory that we need to identify the team, and these four fields we are going to use to identify the teams. So in this cell I have written down the two major functions. One is data preprocess and second one is embeddings. So in data preprocess function I'm just doing text cleaning and text preprocessing. In the first step, I'm concatenating all the text into one sentence, and then I'm converting those sentences into a lowercase sentences. Then I'm doing the tokenization. Tokenization means breaking down a sentence into words, and then I'm checking if there is any word or if there is any word or token is punctuation or a stop word, then I'm removing it. Post doing this, I'm doing stemming process. Stemming process means converting any word to its root word. And then post that, I'm doing normalization. Here normalization means the reverse of tokenization, means convert joining words into a sentence. And then embedding sentence. In embedding sentence, first I'm converting textual data into a numerical vectors, and then post that I'm adding paddings if required. Then in this cell you can see, right, I'm using embedding function on top of data preprocess function. So here I have written one more function which is transform x. This function is for converting input into a more simplified form. In this cell you can see, right, I'm calling up this function and then I'm applying one hot encoding on our target variable, because we are going to use softmax activation function in our output layer. So here comes the main part of this video, where we are implementing our LSTM model, or where we are creating LSTM model. Firstly, we are adding input layer to get the input. The input will be the embeddings of the sentence or the embeddings of the input. And then we are adding LSTM layer here, which is going to take input from the input layer. And then on top of this, we are adding tens layer with these parameters with batch normalization, and then we are adding value activation function to it. ReLU means rectilinear unit, and we are using this activation function to avoid the problem of vanishing gradient. And then we are adding dropout layer here because we don't want any kind of overfitted model. So to avoid overfitting, we use this layer. And then we are adding dense layer, going to be our output layer with these parameters with wedge normalization. And then finally we are adding softmax softmax activation function to our output layer. And then I'm defining loss here, metrics, optimizer, and then finally I'm assembling all the things into a model to get the model ready. Once the model is ready, we can compile it. So in this line I'm compiling the model with this parameter, loss, and metrics. And then we have two more functions, train and predict. In train function we are training this model and getting it saved into a directory with this name. And then in predict function we are getting the predictions from the model. In the ninth cell we have these parameters, and we have this class ready. So I'm calling up this class here, get the model, and then we are building up model here using these parameters. Once the model is built, we can train it. So in this cell we are training the model using these things, like now our data, then learning rate, and the epochs. And then once the model is trained, we can save it. So I have saved my trained model with this name into a directory, and then I'm loading this saved model here. So once the model training is done, we need to verify how well our model is fitted and how accurate it is. To evaluate our model, I have written this code. In the 11th cell you can see we are using this data test.csv to evaluate our model. So that this data is quite long, so I'm taking 100 samples from it, and I'm following the same steps as we did for the training data, like data preprocessing, and then getting the embeddings, and then transforming the embedding. Once these things are done, we are getting the predictions from the model here for the test data. So now here we are evaluating the predictions with the actual data. So here you can see the model is predicting quite well, and it is able to identify all the teams correctly. So we can say the model is quite good to predict. So once the model training is done and the evaluation is done, we can use this model for the inferencing part. So here in this 17th cell, I have written this code for the inferencing part. So first it will ask you for the title. So let's say an example, this is going to be a title. Copy it and paste it here. And then again post title, it will ask you for the body, which means the description. Then give it here. Then it will ask you for the category, then put software there. Then it will ask you for the subcategory for software, then put email. Then it will predict you the team. So let's wait. So you can see here it is predicting software team here. So we have been done multiple things till now, like text cleaning, text preprocessing, then getting embeddings for your textual data, then model building, model training, then model evaluation, and the last we did the inferencing on the saved model, where we were giving some details related to tickets like title, body, category, subcategory, and based on that detail, the model was predicting the team name. And also we can create one separate application using the same model, where we will put all the information related to tickets, and the system will reflect back the team name. So I have created one application using Streamlit. So for your reference, you can go through this website, streamlit.io. Here you will find all the information related to Streamlit, how to create application using Streamlit. You will find here. And apart from the application, you can create multiple kinds of dashboard using Streamlit. So you will find every damn thing related to Streamlit here. So let's back to our application that I have created so far. So till this line I have done the same things as we did in the LSTM Jupyter notebook, and the 82 line I'm loading the saved model. Then from the 87th line the application code is there. I have created four fields: title, body, category, and subcategory. In title, user will have to put the title. In body, user will have to put the description of the ticket. Then in category, user will get these options to select for the ticket category. Once he will select the ticket category, he will get the options in subcategory on the basis of selected category. So one check is there. If all the information is available, then only model will do the prediction. If any of them is missing, then you will get this message: please provide all information. If all the information is available, then you will go inside this conditions. Here we are doing the same things as we did for the training data in the LSTM notebook to get the things trained for your future data. Here future data means the data you are going to receive from these fields. So here I am converting all the information into a dictionary, and then dictionary to a data frame. Then here I'm doing the same data pre-processing and getting embeddings and simplifying and getting the simplified input for the model here. And then in the 126 line I'm getting the team name from the model. And then in the 129 line we are reflecting back the team name in the application using st.write. So let's see how it look like. So here you can see this is how the application will look like, where it will ask you the multiple information. So here you can see an example where I have given the title, monitor, description, category, and subcategory, and based on this information the system is reflecting back the support team. So if let's see for another example, let's change this information and then see what the system will do. Let's put the same information there. Change, and then description. Okay, software, let it run the category, and here you will see the subcategory related to your category. So once you will select the email, you will get the team name here. So let's see what it reflects like. So here you can see the system is predicting the software team for this given information. So this is how this application works. So you can create a similar things using Streamlit, and you will go through the Streamlit application website where you will find the similar information. So there might be a question from you guys: why are we using LSTM here for text classification if we have a machine learning algorithm for text class available for text classification? Yes, we have multiple machine learning algorithms which are available for text classification, but this is an option. You can use machine learning algorithm as well as you can use LSTM or any deep learning algorithm. But this is a demo how we can use LSTM for text classification, or how can we unlock the power of LSTM for text classification. In my next video, I will try to cover up that topic where I will use machine learning algorithm for text classification. Thank you guys. That's all for this video. Before leaving this video, please do like and subscribe my channel to keep me motivated so I can create many more videos for you guys on data science projects. And please don't forget to press bell icon to get the notification for the next video. Thank you guys.